All right, guys, today we're going to talk about how to solve equations where you have variables on both sides of the equal sign. So here's our example, 5x minus 3 equals 13 minus 3x. I've got some x's here on the left and I've got some x's here on the right. I'm going to show you two different ways to solve these equations and you choose the way that you like best. So the first way we're going to go is more of a traditional way to solve the equation. So our goal is to get all of those x's, all of those variables on either the left or the right. It doesn't matter which way you put them. I like to choose the side that has the larger number of variables and put them all on that side. So I've got 5x on the left and negative 3x on the right. So obviously my left has the most amount of x's. So remember, when I'm moving things from one side to the other of the equal sign, I do the opposite. So if this is negative 3x, I'm going to add 3x to both sides. Now the reason that I do the opposite is because I want it to cancel over on that right side and I want to bring it over to the left. So I'm going to say 5x plus 3x is 8x. Okay, so I've still got this negative 3 that I'm going to bring down. I've still got an equal sign and I've still got a 13 that I can just bring straight down. Now we're back at a two-step problem. So I've got the negative 3 here, and I want to move it over to the right side because I want to get these variables all by themselves now that they're together. So I'm going to add 3 to both sides of my equation to cancel off of this left. I'm left with 8x equals 13 plus 3, which is 16. From here, we're down to a one-step problem. 8 times x, so the opposite of that would be to divide by 8. And I have x equals 16 divided by 8, which is 2. And that would be my final answer. Okay, so now I'm going to show you another way to solve this same equation where you have variables on the left as well as the right. This is my trick of how to solve these type of equations. It's called the box method. You've probably heard of box method in a lot of other ways, but sometimes it really helps students see the different parts of the equation when they're put into boxes. So the first thing we want to do is create two boxes, one for the left side of the equation. I'm going to put my equal sign in the middle, and then I'm going to create a box for the right side of the equation. Okay? I'm going to call this box my variable box. And this box is going to be my constants, which are all the other numbers not attached to variables. Okay? So I've got my variables here on the left, and I've got my constants over here on the right. If you wanted to flip-flop these, that would be perfectly fine as well. Okay, so what you're going to do is you're going to look on the left, and you're going to say, do I have any variables on the left? And I do. I have 5x. So I'm going to put a 5x in my first box here. Then I'm going to say, over on the left, do I have any variables? And I do. And it is a negative 3x that I will need to bring over. Now the trick to this is that if you are crossing this center line, if you are crossing the equal sign, which I am, I'm bringing negative 3x from the right to the left, then you have to change the sign. So instead of being negative 3x, I now have positive 3x. Now within this variable box, I'm going to take the two top boxes and I'm going to combine them. So I have a 5x and a 3x. Together that's going to make 8x. Okay? Now we're going to come to the right side of the equation and we're going to do our constants. So we're going to say, okay, since I'm on the right, on my right side box, I'm going to look on the right of the equation and say, do I have any constants? And I do. I have a 13 that I can bring straight down to my box. Okay? Then I'm going to look back over here on the left side and say, do I have any constants that I need to send over? And I do. I have a negative 3 that's going to have to come over to the right. So remember what I said, if you cross the center line or you cross that equal sign, you need to change the sign. So this is negative 3. I'm going to bring it over to the right and it's going to become positive 3. And again, I'm going to take the two top boxes and I'm going to combine them. 3 and 13 give me 16. Okay, so now I have this equation straight across here. 8x equals 16. If I want to rewrite it, I can, but I'm down all the way now to a one-step equation where I can divide out the 8 and I get that x equals 2, just like I did before, the other way that we solved. So we're going to do a couple more examples both ways. I'll do maybe 2 more examples. We'll do it the traditional way as well as the box method so that you can see which way that you like the best. All right, so let's look at this second example. The first time through, I'm going to do it the traditional way where I move all my variables over to one side or the other. Like I said previously, I like to choose the side that has the most amount of the variable in the first place. So my left side, I have 5 n's, and my right side, I have negative 4 n's. Obviously, 5 n's is larger, so we're going to put all of our variables over on that side. So in order to move negative 4n over to the left side, I need to do the opposite of negative, which is positive or plus, and I'm going to do it to both sides. So the reason for that is so that we can get rid of the 4 n's over on the left, over on the right, and we're bringing them to the left. So this leaves me with 14, 5n and 4n make 9n is equal to just that 17 that's over there. Okay? So now my goal is to get all these n's by themselves without any other numbers in the way, so we need to move the 14. Since this is a positive 14, we're going to subtract it because you always do the opposite. And that's going to give me 9n equals 3. 17 minus 14 is 3. From here, we're going to separate our 9 times n by dividing out the 9. And we get that n equals 3 over 9, which reduces to 1/3. And it is perfectly fine that you are left with a fraction as your answer. Just always make sure you reduce that fraction. All right, so now we're going to do the exact same problems. We're going to do it with the box method. So remember we said that you're going to create 2 large boxes with an equal sign in the middle. Again, I'm going to call the left side my variables. And I'm doing this on the left because my left side is the side that has the most amount of variables anyways. If I wanted to call the right side variables, I could and it wouldn't matter. I'd get the same answer. But my right side is going to be my constants here in this case. So we're going to look over here on the left side, and since these are my variables, I'm going to say, do I have any variables over here already on the left? And I do. I have a 5n. So we're going to put 5n in the first box. And then I'm going to say, do I have any variables on the right that need to come over? And I do. I have negative 4n. And our one rule to the box method is that if you're crossing over to the other side of the equal sign, the sign must change. Because this is a negative 4n and I'm crossing over, it's going to become a positive 4n. Okay? I'm going to take my top 2 boxes because they should be like terms at this point, and I'm going to combine them. 5n and 4n make 9n. Okay? Then we're going to look at our constants. My constant box is on the right side, so we're going to look at the right side and say, do I have any constants over there? And I do. I have a 17. Okay? Then I'm going to look at my left side and say, do I have any constants that need to come over? And I do. I have a 14. And if I'm going to bring that 14 all the way over, it needs to change signs and become a negative 14. Okay? Again, I should have like terms in this box. They should be both constants, so we're going to combine them. A negative 14 and a 17 are going to make 3. So now I'm left with the same one-step problem I was before, the other way that I did it, where I have 9n equals 3, and I have to divide both sides by 9, leaving me n equals 1/3, because 3/9 reduces to 1/3. Okay, so now I'm going to show you a problem that's a little bit harder because there is one step you have to do before you can start solving it. So the first step that we're going to do in this problem is that we see parentheses, we should know to distribute. So I'm going to go ahead and distribute my 4 over here on the left, and I'm going to distribute my 3 over here on the right. So before I solve this the traditional way and before I solve this the box method, I have to do the same thing. I have to distribute first or I can't keep going. So once I distribute, I get 16 minus 4w equals 6w plus 6. Now I've got the left side as simple as I can make it. I've got the right side as simple as I can make it, and I can continue to solve. Okay, so again, I'm going to show you both ways from here. I'm going to choose the side of the equal sign that has the most of the variables. So in this case, the most W's. I've got a negative 4W and a 6W, so I want to put my variables over here with the 6W. So I'm going to look at my negative 4W and I'm going to do the opposite. The opposite would be adding 4W. And I'm going to do it to both sides. The point of that is so that it'll cancel here. This leaves me with a 16 equals 6W plus 4W, which is 10W plus 6. Okay, so now my job is to get that variable by itself, and this plus 6 is in the way. So we'll subtract it, and we get 10 equals 10W. So we divide out our 10, and 1 equals W. Now what you'll notice on this one is that our variable W ended up on the right side, but that's perfectly fine. You could also rewrite your answer as W equals 1. There is no difference. The reason it ended up on that right side is we chose to put our variables on the right side. All right, so if you want to solve it with the box method, you're still going to have to do the very first step that we talked about, which was to distribute. So you're still going to start with 16 minus 4W equals 6W plus 6. Then we can move on to our box method. Once I have the left simple, the right as simple as it will go, I can start drawing my boxes. So this time I am going to switch it up, and I'm going to say that the right is going to be my variables. And I'm doing that because the 6W is the most amount of variables, and those are on the right side. My left side in this case are going to be called my constants. So we're solving this the exact same way. We just changed where we put our variables and our constants. So with the left side, we're going to look for constants, and we're going to look at the left side of this equation. I do have a constant here, which is a 16, so I'm going to bring it straight down. I'm going to look over on the right-hand side, and I have a constant there, which is a 6, but we need to bring it over to the other side. And remember, when we bring it over, we change the sign. So instead of a 6, it's going to become a negative 6. And then we're going to combine our like terms that are here in these top two boxes. So 16 and negative 6 leave me with 10. Okay, then I'm going to move to my variable side, which is on the right. So I'm going to say I already have 6W's over on the right, so we're going to put those there. I need to bring over the negative 4W, but because I'm bringing it over, it's going to change to a positive 4W, and then I combine my W's, which give me 10. So now I'm left with that same equation that I was left with before. 10 equals 10W. We'll divide both sides by 10, and again get W equals 1. So either way you want to solve it works. You choose the way that you like best.